8, 3, and 8, 4, tangent, sine, and cosine ratios. Tangent, sine, and cosine are what we call trigonometric ratios, and these are ratios of lengths of two sides in a right triangle. What we use these for are to find measures of angles or to find lengths of sides within a right triangle. When we use these three, the way we will use them at this point, we have to be working with a right triangle. So our three trigonometric ratios, again, are tangent, sine, and cosine. Tangent, we will be able to abbreviate when we write it as TAN. When you read it, make sure you say tangent. When you write it, you can write the abbreviation. When you write sine, you can abbreviate that SIN. And then cosine is abbreviated as COS. So all three of these would be abbreviated with the first three letters of the name of the ratio. Now, when we go to set up our ratio, first thing we have to understand is that the triangle, and especially what angle you're working from within the triangle, determines how these sides are going to be labeled. The only one that doesn't change is always going to be your hypotenuse. The hypotenuse is always the side that's opposite from the right angle, so it wouldn't really matter which angle you're working from. Hypotenuse is always going to be the hypotenuse. So now, just for this instance, let's say I'm working from this lower left angle in this triangle. So I'm going to put this theta here. Okay, this is the Greek letter theta. We use that a lot in math when we want it to represent an angle. It's really just treated like a variable. So another way to show that this is the angle that you are working in. Hold on one second, let me fix this. There we go. Another way to show that this is the angle that you're working in is to just put an arc within that angle. This isn't, it looks similar or the same actually as saying that this angle is congruent to something, but in this case it's really just marking so you visually can see which angle you're using. So now from this angle theta here, two other sides that we would have to label would be the opposite side, which is the leg of the right triangle that the angle does not touch. And then you have what's called your adjacent side, and the term adjacent means next to. So that's the leg that's next to or that touches the angle that you are working from. So to help us set up these trig ratios, there's this saying of SOHCAHTOA. The SO stands for sine, CA stands for cosine, and TOA helps with tangent. So if I'm working with tangent, the TOA tells me that tangent is always equal to the opposite side over the adjacent side. That's what the TOA represents. The sine of an angle, the SO in SOHCAHTOA, this one I just had to move over so that I could make it fit. That's always opposite over hypotenuse. So sine is opposite over hypotenuse, SOH. Finally, cosine is the CA from SOHCAHTOA. Cosine is always adjacent over hypotenuse. So now using these three trig ratios, we have to write the tangent, sine, and cosine ratios for the angles T and U in this right triangle. Now if we need to write these ratios, first thing we have to make sure of is we have all three sides of the right triangle. Let's suppose for a second that we didn't have all three sides. We just had two of them. What would you be able to use to find the third side? To find the third side of a right triangle, when you're given two sides, you have to use Pythagorean theorem, the very first thing that was covered in this chapter. So now back to writing these ratios. When you write ratios are just fractions, so you need to make sure you always reduce when possible. And when you write the ratios, notice how I have them laid out here. You always have to put which trig ratio you're using, and then you have to put the name of the angle for which ratio it's the angle it's working from. So in this case, the sine of angle T, sine is opposite over hypotenuse, so I would be able to write 3/5. The cosine of angle t, actually I should do this. Notice how I've labeled the different sides based on working from angle t. So the cosine now is the adjacent over the hypotenuse. That'd be 4 over 5. Whoops. I don't know why this keeps doing that. Fix this one more time. And then tangent opposite over adjacent is 3/4. So now I'd like you to actually go through and do the sine of angle u, cosine of angle u, and tangent of angle u. If I'm working from angle u, the hypotenuse would still stay the same, but now the 3 is the adjacent side and the 4 is the opposite. So sine being opposite over hypotenuse would be 4/5 this time. Cosine would be 3/5. Tangent would be 4/3. The next thing we have to do is use these trig ratios to help us find the side lengths of a right triangle. Notice now you're only given one specific side length, so you can't use Pythagorean theorem. You have to have two side lengths to use Pythagorean theorem to find the third. So now we're given an angle and one side length. That is a huge clue that we have to use trigonometry. Now when you do trigonometry, big thing you have to do is you have to make sure your calculators are in degree mode. So let's talk about checking to see if they're in degree mode real quick. If you have a scientific calculator like the picture on the left, you should see down in this bottom right hand corner of your screen DEG. If you don't see DEG there, you might see RAD. Okay, what you need to do if you see something other than DEG is you need to push this button, the DRG button, and select DEG. If you have a graphing calculator, you have to hit your mode button, which you can see here is in red behind this cursor in the picture. That'll take you to a screen that looks like this. Then you use your arrow keys to come down to where it says radian in degree, and you're going to use your arrow key to the right and so that the kind of box is flashing around degree, and you're going to hit enter so that this degree would be outlined in the dark box instead of radian. So now actually using the trig ratios. So for A, what I need to do is I need to look at my triangle, and if I'm working from the 22-degree angle that I'm given here, I need to label, or at least be able to mentally label, that the x is the opposite and the 5 is the adjacent. So now I have to think back. If I'm using SOHCAHTOA, okay, it might not be a bad idea to write it down again if you need to. If I'm using SOHCAHTOA, which one of those three trig ratios uses the opposite and the adjacent? That would be tangent. So I need to write the trig ratio first. So tangent of the angle is 22 equals opposite over adjacent. So that would be x over 5. Now one way to actually figure out what you would do to find x would be, think of this as a proportion. The tangent, you'd be able to say, has a denominator of 1. So if you cross multiplied here, you would have 1 times x, that would just be x, and you'd have 5 times the tangent of 22. And now this is what you would type in your calculator. You would just hit 5 times tangent 22, and you would round to the nearest thousandth, as it says in the problem, and you would get 2.020. Remember, thousandth, means 3 decimal places. So this is what the work that I would expect to see would look like. The first step is setting up the trig ratio. The second step is showing me what you're going to put in your calculator. And the third step is giving me your final answer. So now for part B, I'm working from the 60-degree angle. 10 is my adjacent, x is my hypotenuse. So this time we have to use cosine. So our setup would be cosine of 60 equals 10 over x. Now again, if I think of this as a proportion because the cosine of 60 has a denominator of 1, and I cross multiply, I would get x times 60, x times cosine of 60, excuse me, equals 10. Now I have to think, what would I have to do to solve for x? I'd have to divide by the cosine of 60 on both sides. That is just a numerical value, so you are allowed to divide by it. So that would those would cancel each other out, so that you would still have x by itself. So now in the calculator, the 10 divided by cosine of 60 is what you would be typing in, and you would find that x equals 20. For part C, x is the opposite side, 9 is the hypotenuse, so opposite and hypotenuse is sine. So we'd have sine of 10 equals x over 9. Again, think of this as a proportion. That is a denominator of 1. Whether you need to write it in there or you can just do it mentally, it's up to you. So now if I cross multiply, I would have x equals 9 times the sine of 10. That's, again, what I'm going to type in the calculator, so I need to show it. This would give me 1.563. Our fourth example, from the 89-degree angle, we have the opposite x and the adjacent 3, so that is a tangent. So I set this up as tangent of 89 equals x over 3. Cross multiply, I would have x equals 3 times the tangent of 89, and then type that in the calculator. I would get 171.870. The next thing I'll have you do is I'll have you work through E, F, and G, and H, excuse me, but we're going to do those next 4. So for letter E, what would you use as your trig function? Would you use sine, cosine, or tangent? Now, what is the value of x for letter E? For F, which trig function would you use? And find the value of x. Same thing with letter G. Which trig function would you use? And then find the value of x. And then letter H. Which trig function would you use here? And what is the value of x? Hopefully, when you worked through these, you found that you would have 11.126 for x, for the x value in letter E. Letter F, x is approximately 18.930. For G, x should be approximately 37.637. So if you need to fix any of those, please make sure you do so. If you need help putting these in the calculator, make sure you ask. I'm more than happy to help. And then for letter H, hopefully you used cosine and found that you would get negative 3.84, but we have to realize x is representing a side length, and we can't have negative side length, so this is not possible. So I would expect you to write not possible. And the reason it's not possible, we can only do right triangle trig with acute angles. Notice this 92-degree angle, that's not acute. This is actually not possible to have a triangle with a 92-degree angle as well as a 90-degree angle, because then you've already exceeded the 180-degree total the triangle is supposed to have. So big thing, make sure you look out for problems where you're trying to do trig with angles that are not acute. That would not be possible. All right, the next thing we'll talk about is finding an angle measure using right triangle trigonometry. So here our job is to find the measure of angle x using the tangent ratio. So first thing I'll do, since I know I have to work from angle x, since this is the angle I'm trying to find, I'll label my sides. So there's my hypotenuse, my adjacent, and my opposite. Now if I'm supposed to write or find the measure of an angle, we have to use the inverse of the trig function. So we'd still set everything up the normal way at first. We'll do our trig function, in which this case is tangent. But now we don't know the measure of the angle, so we put the name of the angle after the trig function. So tangent of angle x is equal to 6 over 8. That's opposite over adjacent from our picture. Now the next step, what you're going to type in the calculator, this is where the difference comes in. Now we're finding the measure of angle x, and that is equal to the inverse tangent of 6 over 8. Now, to get the inverse tangent on your calculator, you have to hit your second button, and then the tangent button, and then you would type in 6 over 8. And when you hit equals, you should find that the measure of angle x is approximately 36.870. Now I'd like you to find the measure of angle h using both the sine and cosine ratios. Follow the work that is shown up here in number 5. So yes, you're going to do this twice. Yes, the measure of angle h should be the same both times. I just want you to get a little bit of practice actually finding it using your calculator, writing out all the work. So what the work should look like and what your answer should be both times that you did this, should have found that the measure of angle h is 53.130. And again, please double check that your work is written the way that you see here. This is something that I'm going to make sure that you write for me so that I can tell whether or not you're going through the correct process. The last one that we are going to do. If we have a 20-foot wire supporting a flagpole, it forms a 35-degree angle with that flagpole. Our job is to figure out how tall the flagpole is. And then we have to give our answer in feet and inches to the nearest inch. So first thing you want to do is get yourself a picture, a real quick diagram. All this is a right triangle. Do not worry about trying to draw a flagpole or anything special like that. It's not the point of doing these problems. So now notice I've labeled my picture. The vertical leg here would represent the flagpole. The diagonal hypotenuse would represent that wire. It's called a guy wire a lot of times. This wire that's supporting the flagpole. The 35-degree angle is formed by the wire and the flagpole, so it's up here in the top corner. And I'm trying to figure out the height of that flagpole, so my x variable goes on that vertical leg. So the first thing we have to do is figure out what that value of x is using one of the 3 trigonometric ratios. Working from that 35-degree angle, the x is the adjacent, the 20 is the hypotenuse. So this should tell us that we are using cosine. So right now I'd like you to use cosine and figure out what the value of x is and round that to the nearest thousandth. Hopefully you found that the value of x is 16.383. Now, typically that would be good, except for the fact that we are told that we need to give our answer in feet and inches to the nearest inch. So this would just be a number of feet if we were to keep it that way. But since the question is asking for it differently, we have to now figure out how to answer the question in the format that it is asking for. So the first thing, the whole number part of your answer, the 16 feet, we know that this thing is going to be 16 feet, and then whatever number of inches. Really the work that we have to do now is figure out how many inches this 0.383 feet represents. So what we do is we take that 0.383, we take the decimal portion of the answer that we found, and we convert it. Well, hopefully we all know that there's 12 inches in a foot. So this is called dimensional analysis or unit analysis. If you haven't seen it yet, you will see that, especially in science class. Plus, it will come back around in math as well. So the whole point of setting it up this way, so that the feet is in the numerator and 1 in the denominators, those would basically cancel each other out, so you'd just be left with inches. If you just multiply 0.383 times 12, you would find that that's 4.569 inches. And then again, to the nearest inch, your final answer for this would be 16 feet, 5 inches. So now if you need to, please go back and review any part of the video that you were a little bit confused on, and we will pick it up from there when we're back in class.